Welcome to part 4 of the Ohm's Law series. So far we have covered voltage, resistance, and current. Finally, we have made it to the namesake of this series, Ohm's Law. Ohm's Law is electricity's relationship between voltage, resistance, and current. In this video, we will explore that relationship. We can't talk about Ohm's Law without talking about George Ohm. Like we covered in our previous videos on resistance, Ohm was a German physicist and mathematician. While working on experiments with electricity while he was working as a teacher, he discovered a direct relationship between voltage, current, and resistance. In his words, Ohm stated, "The communication of electricity occurred between contiguous particles." Ohm's Law first appeared in the famous book, The Galvanic Circuit Investigated Mathematically, that Ohm published in 1827, in which he gave his complete theory of electricity. In this work, he stated the law for electromotive force acting between the extremities of any part of a circuit is the product of the strength of the current and the resistance of that part of the circuit. In other words, and in plain English, voltage from a circuit is directly proportional to its current and resistance of the conductors. In honor of this discovery, we call this relationship Ohm's Law. As an equation, Ohm's Law is a very simple algebraic formula, V equals IR, or voltage equals current multiplied by resistance. Calculating Ohm's Law is easy algebra. With only 3 variables, the relationship is direct and proportional across the equal sign. By knowing any 2 values of voltage, current, or resistance, we can use Ohm's Law to find the third missing value. We can also see this visually here. As voltage changes and resistance stays the same, this means that current has to change proportionally. Likewise, as resistance changes and voltage stays the same, that means that current also has to change proportionally. Lastly, to wrap up this video, here's a tip for calculating Ohm's Law. If you can remember the Ohm's Law triangle and draw it on a piece of paper, the rest is easy. Covering the unknown in the Ohm's Law triangle gives the formula in terms of the remaining values. If you cover the V, then the remaining variables are I next to R, so V equals IR. If you cover the I, the remaining variables are V over R, so I equals V over R. If you cover R, then the remaining variables are V over I, so R equals V over I. I hope that the video and the 3 videos before this in this series provided you with a foundational understanding of voltage, current, and resistance and the relationship between them that we call Ohm's Law. Thank you for watching, and remember to like and subscribe if you liked this video. As always, make moves.